Hi everyone, it's Diana back for another video. So I was looking at this moon some more and I realized why it's such a problem. I mean, I knew there was a problem, but I don't think I've articulated exactly what it was. So remember I was showing you the image in my text of the far side of the moon, and that's called the Mare Orientale, I guess. And it seems to take up, all the rings included, seem to take up about a third of the moon's surface. So here are the two together. And I was pointing out the last time there was this line in the center, running down the center. And I think I should show you my better image here. It's a little more close. So the way it looks here is that these craters, well, this looks like a crater, and this side, they don't really look like craters, they look like bubbles. And you can use some sort of perspective to make it go in and out from crater to bubble. Now, why is that? Well, I think it's partly because of, they're side by side, and the light is wrong, like totally wrong. I mean, if this were a light directly in front of a frontal lighting, I would say, this shadow would not be here. And this shadow would not be here. It would be actually totally reversed. The shadow would be here, and this shadow would be here. So this is the problem with this image. I've got it totally opposite. And and then, I found this other image. This is topographical. It appears to be, the same. If you look at them side by side, they appear to be the same image, except for the topography and the scale, color scale here. So, but the line isn't there anymore. So I guess they saw my last video and they got rid of that line. So, anyway, so it brought me to a few other things too. That was the Apollo image. Apollo 16 crew took that picture, and that doesn't really look like, after looking at my text and the one over here, they don't seem to match up either. But anyway, so that will take me to, oops, that one. This one. That is kind of comical. It really is. I guess if you believe in NASA, and it looks kind of normal to you, but it doesn't look normal to us for various reasons. And I'm sure people have covered it before. Like, for instance, the clouds and how long it takes for that rotation, and that sun highlight in the middle there. Anyway, so this is what it brings to my mind, and I've never really, well, I guess I have thought about certain things, but where do you take it, right? So this image brings to mind, how do you make a ball? I mean, really, how do you make a ball? And how do you make a ball in space? So when you think about it, there's got to be some sort of resistance. Now, I know everyone's going to shout gravity. Okay. So, when I think about, let's say they tell us about the Big Bang, right? So all this stuff went suddenly shot into space, in this vacuum of space, and it's just like traveling at all these high speeds. And somehow they get caught up in these orbits or whatever. I mean, like, think about that. It's kind of preposterous, I think. And then when you think about forming a ball, you think of like something resisting on the outside, and it kind of has to, I guess, make roll. I'm just like trying to figure this out now here in front of you, basically. You're trying to roll this thing around and giving it equal pressure, equal whatever, to make a, these are perfect balls. Look at them. They're perfect. And So when you think of something traveling, like say for instance the Earth is traveling with the solar system now at, depending on what you're reading, 515,000 miles per hour. That's 300 times faster than a bullet. And it's also rotating at 1,000 miles an hour, and only on its axis now. It's not rolling in all different directions to form this ball. It's only on its axis. So, and then you've got it traveling in another direction around the sun at 67,000 miles per hour. So you have all these different speeds, different directions. How do you make a ball out of that? And I think it's also, if I'm not mistaken, traveling with the galaxy at like 1,000,000 miles an hour. I'm not sure if it's traveling with the galaxy or the galaxy is traveling around it, but it should be traveling with the galaxy if you have the Big Bang and everything's just like, you know, coordinated, right? It's just, I mean, it all sounds very crazy. So, let me know what you think. And maybe you know how they make balls in space. I don't get it at all. We just accept this stuff. You know, I did study astronomy, and people, you know, will say to me, you know, in comments, you know, I might make a nice little comment, you know, to a video that I've watched, and then somebody will come along and, you know, like swoop down on me and say something, and they'll say something like, well, if you studied astronomy, you wouldn't say these things or whatever. But the reality is, I did study astronomy and basically the solar system in specifically. And because I do question this stuff, and I don't say things that will, you know, support it. I'll say something opposite, or I'll question and criticize it. So, you know, people will also say, well, you should stick to your dancing and your painting. It's like, wait a minute. I have a brain too. You know, I did a lot of critical thinking in college, 8 years of it. And in my astronomy class, you know, it was mostly memorization, really. Nobody questioned anything, really. The professor doesn't even question anything. The professor just parrots, you know, what, you know, we're supposed to learn. And we just memorize it. And since, you know, I like science, and it kind of came easy for me. I mean, we had a lot of material to memorize. And I don't mean to brag, but, you know, I did very well, and the professor, you know, told the class if we got, I think it was 95 or above by the time we got to the final exam, we didn't have to take the final exam. And I didn't have to take the final exam. And I'd also like to point out that my last exam, I got a 100 score. And it happened to be, when this is a large class now, large lecture room full of students. And there were 2 100s in the whole class. And I'm going to tell you, the other 100 was achieved by another artist. Okay, so we do know how to learn. So, and I know this because when he hands out the test, he also hands out a sheet that gives us the comparisons on it, like how many hundreds, how many 90s, how many 40s, etc. were in this, you know, class. So anyway, I'll leave you on that note. So let me know if you can come up with an idea of how to make a perfect ball in space. Okay? Thanks so much for listening, and I will see you again, or talk to you again. Bye.